Hi Ignacio, I'm happy that you're here, and I would like to give you the opportunity to say a bit about yourself, the company, and then I have a few questions for you.
Fantastic. Thanks for having me.
Yeah, maybe you tell us a little bit about the company.
So I am representing Novanta here in the summit. And Novanta is a global company. It has sites all over, although the headquarters are in Boston, in the U.S. And the company has been grown very strong in the medical industry, in the medical devices. We manufacture components for advanced medical applications, and we have a strong presence and a lot of expertise, specifically in surgical robots. Now, what we did is take this knowledge accumulated in that complex field and to put it into these other sectors, like these emerging humanoids technologies.
There's a lot of talk about humanoids and safety. So my question here is how to approach the functional safety in humanoids, but on an actuator level. Maybe you can tell me a little bit about this.
So I believe the functional safety in humanoids is most probably the hot topic of this conference, and it has been a hot topic since the later year, I would say, because we are kind of realizing that humanoids are strong devices, inherently dangerous. I don't say we should fear them because the danger is more like a physical thing. It's something very dummy. They could fall, they could grab a wrong thing, they could act in a way that a person with a much more advanced intelligence would not. So we don't expect for them to do this kind of stuff. Then it requires a functional safety approach that roboticists, given that it's generally their field of expertise, I believe they're approaching from a system level. And that's okay. So it must be approached from a system level. But we realize that in the moment that you want to certify this, just to clarify, there's still no certifications in place, but they are doing them. They are actually studying them and writing them. So it's going to come very soon because the industry is demanding that. The moment that you want to certify that, you have to make clear that the robot is able to respond in a scenario in which something is failing. Failing, I mean blowing up, like something broke. And then the capabilities of your robot are not complete. The robot does not have all the capabilities. Even in that case, you need to be able to perform a safety function that would reduce hazard.
Now, give me an example.
For instance, let's assume that the supply cable of the knee joint of one of the legs just ripped off. So this actuator is no longer capable of generating torque, meaning that not only the robot could fall when it steps in that leg towards one person, but the fact that this is most probably going to generate an alert signal that it's going to trigger the more common reaction to that signal. Now, functional safety, it's a topic that it's a little bit difficult to get into. We would need more time to do that, and it's not possible. But one thing that I can say is that in safety of machinery, the typical reaction is stopping everything in a passive mode, like cutting supply. And when you do this, the robot drops. Yeah. So, given the fact that humanoids are not inherently stable, they are self-balancing machines, you need a different safe state. You need an active safe state. And as far as we know, this does not exist. And this is exactly what we are providing right now. This is the innovation that we bring to the show. So if you follow these precepts, you are not only going to get a solution in the robot level when everything is working fine, but in front of this failure, you also have a building block and a strategy that will allow you to keep performing this safety function even when you normally could not. So with these functionalities, for instance, we are able to generate braking torque even when the supply is gone. Going back to the example that I just said.
I mean, in the manufacturing space or in a factory, you do have a cage around that. You do have some lasers or some different kind of safety options. And if it's not if there is no direct contact, but we would like to have humanoids walking around us, right, in our homes around us. So here, the safety topic is huge, even though at the moment everyone is trying to get them to a stage where they're being helpful in the first place, right? But these things need to be developed in parallel, not afterwards.
100%. So we have seen how the first application in which these manufacturers are focusing are basically automotive industry, then logistics, then house care or elderly care, and they almost one-to-one correspond to the typical approaches between in the proximity between the robot and the human. So in factories they can be in a fence that would be coexistent. In a logistics application, given the fact that they need to move from point A to point B, which is distant, they need to be cooperative. So at least know that the human is there and do something to prevent hazard to the human.
So slow down, for example.
And in hospitals or elderly care or even in household, you need to be in physical touch with the user. So you need a collaborative approach. I believe that we are not there, but cooperative is about to happen.
I mean, there's a lot of humanoid companies out there, and what's your take on where are they with focusing on that and talking about this and putting this into the spotlight as much as generating revenue or value for companies?
So I believe that those companies that are already targeting a logistics application, they are actively speaking on providing solutions. And those companies talking about the let's say automotive or more industrial approach, I think they are waiting for the first one to generate a solution that would develop into a standard, and then later on maybe try these strategies out, because it's extremely costly to develop these strategies, and the priority for these companies, I believe, is to deploy a fleet of robots and demonstrate that they are able to produce in volume, so that the robot is scalable.
Yeah.
But then, once this is done, the second priority is going to be make them safe to coexist with humans. So I believe they are waiting for this. And in the household case, that's more chaotic. So probably they are looking for a solution, but I believe this is way more complex. And maybe in the 2-3 upcoming years, we're going to see a path towards that. But by now, I'm not sure.
We were talking about components from humanoids. When the word drives come, is there something that we can talk about?
Yes. So a typical approach, as far the experience that we have gathered by dealing with a lot of these robot manufacturers, is they prefer to have the complexities in terms of the motion gathered in the joint. To make the linkages simpler and the rest of the robot simpler. It's better for testing. It has a lot of advantages, but that makes the joint a hell of a complicated piece of technology, because it has to pack a lot, and mass is super important, inertia is super important, power consumption is super important. Then it not only needs to be small and ultra capable, but it needs to be reliable. It's like I want it all in this device. So this is where we are providing one of the top technologies in the world in terms of drive. The drive will be the controller of the motor. Like for instance, we approach efficiency by using gallium nitride as the switched element. Gallium nitride is, I believe, the future of the semiconductors for power electronics in low voltage, because it outperforms silicon in almost every category. And you simply can reach higher efficiencies, which means lesser generation of heat, which means you can do it smaller and still it's going to respond. So we have been doing power stages with gallium nitride like for 9 or almost 10 years. We were the pioneers in that field, and only in the very, very recent years, and I would say even year, other competitors are starting there. So we have a bunch of experience and I would say technological advantage when it comes to our solution there. And it's not easy to get this into a very small form factor drive, but once you do it, the miniaturization, the advantages that it provides, for instance, one of the things that you can do is to merge several elements into this PCB, because suddenly you shrink it to a smaller size, and then you not only have a drive, now it's a drive plus an encoder, or plus 2 encoders, or a drive plus IMU. So this is what we try to offer as a solution for our customers that demand like the maximum shrinkage of everything into these joints.
You were talking about solutions. The last time I was coming across you guys was when we're talking about the platform you guys have.
Yes. So these solutions that I was just mentioning, in the past we would have developed a product line with that. Now we did a different reading of the humanoid industry, and we developed what we call a platform. A platform for us, it's a collection of design resources that are tested and validated to a very great amount. So they are very sure very safe to use, and we use them like a puzzle. We do our origami with them, and then we become ultra fast in tailoring specific designs to the need not only of a manufacturer but a joint specifically. And in a few months we can have a single PCB that is developing the highest amount of power density. It also has an encoder. You can select optical, magnetic, or inductive because we know how to do the three of them. It has the IMU embedded for advanced functionalities like compensating for the lack of stiffness of your linkages in the robot. It also has an input stage if you want to put a torque sensor on it and close the loop to have better performing torque sensor, if you want to invest in the cost of the torque sensor. And even if Novanta is a specialist in manufacturing motion control components, so we have our own catalog, we don't force our customers to use our components because they already have a solution that they want to improve, and they may be happy with many of the components that they are already using. So we adapt to them and we use the components that our customers demand, and we build at this puzzle in an ultra small form factor, and it becomes the heart of the joint. And we also pack this functional safety solution, which entails a whole new architecture around it, an electronics architecture, so that you already can have these advanced safety functions that are tailored to humanoids specifically, including this safe state that will allow you to break the motors even when you don't have supply or communications.
So this is where the platform approach comes into place. Having the capability or the possibilities to use your products, but also working together with existing solutions that they have.
Correct, and we do it like ultra fast and with a level of customization that goes like anywhere that our customers want to reach. Yeah.
When I spoke with the other ones yesterday, there's always my question. So what's ahead for you guys? When I'm looking at the roadmap or the milestones within the next few months and years, is there anything that we should keep an eye on?
Sure. So first of all, our Volcano platform is already working, but as much as we advance by serving new customers, it's evolving. So you should expect an evolution on that. And the philosophy that we have placed in our previous lines of product has been develop something in which the core technologies are extremely packed up and then becomes a component. But typically, you would require surrounding electronics or adapters to get this technology tailored to the needs of a specific application. This typically has the shape of a carrier board or an interface board. Mm-hmm. Then in the past, these boards had to be developed or by our customers, or they had to contract our services to get this developed. But what we are doing is to have a library of online resources that are completely free of use and download with actual projects and the full design fonts for them. It's no IP, it's completely free, so customers can get these designs, modify it at their will, and the part that they keep or that they reuse reduces their time to market a lot and the risk of failure. So you already have electronics that are tested, there are designs by experts who knows how to do it, design for manufacturing, design to reduce EMI, and all these things that typically are going to generate trouble and force you to iterate. So if you reduce this iteration, you can get this solved much faster and in much cheaper fashion. So I believe that the next that we are going to do to complement our Volcano platform is to keep adding this kind of resources, which I believe our customers like a lot.
I mean, when it comes to solutions and you talk to customers, this is and we spoke about this in the last few days as well, the ease of use, how easy the existing thing that you have is for new components or new products that you incorporate in the existing product line or workflow. So I think this is definitely something that more and more companies really understand, that the effort and time, money you need to put into to make things work as a whole, I think is very important.
The ease of use impacts reliability, but especially impacts time. It's the ease of use translates into time to market. So when you go to other industries and they say we are rushing because we have to develop this product to be in the market in 3 years. But here with the humanoid is absolutely different. They say we are rushing because we have to have something as complex as a humanoid, which is extremely complex, in 4 months.
Yeah, crazy.
But it's being the first or not. It's everything. So for them it's crucial to develop fast, and we need to provide a solution that allows them to develop fast.
Yeah, I'm happy that more and more companies are really digging into that, into the understanding here the real pain and the need of customers, and trying to find solutions that are serving more than just one thing. Yeah, I'm happy that you took some time and gave us some insights, real technical insights. I think this was one of the most technical interviews that we had today.
Sorry about that.
No, the good thing is that this is a Humanoid Summit, and it is about humanoids. And as you said, they are very complex. And here showing how far into detail you can go about every single aspect of that, right? This is what's I think so interesting, and it shows the level. So this is deep tech. This shows the level of expertise in just one single thing, right? And
as I
so,
said, we have grown the experts in this. We digged a lot.
Yeah.
But I appreciate your comment. Yes.
Yeah, thanks for taking the time, and we keep an eye on what's happening next for you guys.
Thank you.
Take care.